All right, in this video, we're going to be talking about recursion and exponential functions. So it says different balls bounce at various heights depending on things like the type of ball, the pressure of air in the ball, and the surface on which it is bounced. The rebound percentage of a ball is found by determining the quotient of the rebound height, that is the height of each bounce, to the height of the ball before the bounce converted to a percentage. So anytime you see the word quotient, we're going to be working with fraction, okay, because that's what a quotient is, right? So I have an example here. I have a ball. It says collect data on a bouncing ball that show the maximum height of at least 5 bounces of the ball. Then make a scatter plot of the maximum height as a function of the bounce number. Let bounce 0 be the initial drop height of the ball. So I've got the bounce number, so 0, 1, 2, 3, 4, 5. And then I've got the height. And I've got an example, just measurements right here. So originally, the height in inches, 36. So this was 3 feet off the ground, right? And after one bounce is 27.36. 2 bounces is 20.88, 59.96, and so on. So the first thing I'm going to do is I'm going to make a graph. I've got this empty graph right here, and we're just going to plot all of these points. So I've got the initial height of 0 is 36. So that's about right here. And then after one bounce is 27.6. And then 20.88. 15.96. 12.6. And 9.72. And so you can see we've got this graph following a curved line right here. Just like that. Now it says for number 2, find the average rebound percentage for your ball and show your work. So just like it's set up here, the rebound percentage of a ball is found by determining the quotient, as in fraction, of the rebound height to the height of the ball before the bounce. So we've got, we're not going to have a value for the first one, for bounce 0, because we didn't have a bounce yet, right? So we only have one piece of data. But for the next one, after one bounce, we need to find the rebound percentage by taking the height after one bounce and divide it by the height before that. So we've got 27.36 divided by 36. And then to get a percentage, we multiply by 100. And then for the next one, I'm going to do the same thing, but with the new numbers. We got 20.88 divided by 27.36 and multiply by 100. And I'm just going to go down the list and do this for each one. Okay, and so if I take these values, if I just multiply or divide out 27.36 by 36 and then multiply it by 100, I should get a percentage of 76, so about 76%. If I do the next one, then I should get 76%. The next one would equal 76, and not all of these have to be exact, so it might be slightly different. Like for example, this next one is 79%. And then the last one was 77%. And so we've got the rebound percentage for after each bounce, okay? And then it asked us to find an average. So all I need to do is I just need to average these bounce rebound percentages together. So my average is going to equal 76 plus 76 plus 76 plus 79 plus 77, and then divide it all by 5 because I have 5 numbers. And so that's going to equal about 76.8%. All right, and then question 3, it says, tennis balls are sealed in a pressurized container to maintain the rebound percentage of the balls. A tennis ball has a rebound percentage of 55%. I'm going to highlight that. Anytime I get info, I'm just going to highlight. And just to note, 55% is the same thing as 0.55, okay? Now it says when it is taken out of the pressurized can. Suppose a tennis ball is dropped from a height of 2 meters onto a tennis court. Use the rebound rate given to predict the height of the ball's first 7 bounces. So I need to predict the height of each of these bounces using, I know that the starting height is 2 meters and the rebound percentage is 55%. So after one bounce, okay, it's going to be the same thing as before. I have my previous height and multiply it by my rebound percentage. So if I do that for each one, so I'm going to get 1.1 here. Then the next one's going to be 1.1 times 0.55. It's going to give me 0.605. And I'm just going down the list. 0.605 times 0.55. I'm going to get 0.33. I'm just going to keep going. Okay, so now I've found the height after each bounce. So in question 3, I'm going to go back a second. In question 2, we were given the heights and we had to find the average bounce rebound percentage. In question 3, we are given the rebound percentage and we have to find the heights. Now, number 4 says write a recursive rule for the height of the ball for each successive bounce. So if I'm doing a recursive rule, remember it is the height of the next bounce, so n plus 1, is equal to the height of the current bounce times 0.55. And I'm going to specify just a little bit where n has to equal 0, 1, 2, 3, so on. And our starting value, h sub 0, is equal to 2. And now it says, describe in words how the height of each bounce is calculated from the height of the previous bounce. So remember, it's just 55% of the original bounce or the previous bounce. So we just say the height of each bounce is 0.55 times the previous height. And now number 6 says, enter the bounce height data into a graphing calculator and make a scatter plot and then sketch the graph below. So if you were to sketch this graph, we know that the starting height is 2 meters. So my y-axis is going to represent my height, and then my x-axis is going to represent my bounces. Since my height is 2 meters at the start, I don't even have to go above 2 meters here. So I'm going to say that here is 0, here is 1, here is 2. Okay, and then I'm doing 7 bounces, so I've got 1, 2, 3, 4, 5, 6, 7. Okay, so after after 0 bounces, we're at 2 meters. After 1 bounce, we're at 1.1. 2 bounces, 0.605. 3 bounces, 0.33. 4 bounces, 0.183. 0.101. 0.065. And 0.31. 0.03. And so we've got a curve or a line that follows this curve right here. And as you go on, I mean, you've seen a ball before. When you drop it, it bounces, and it bounces for a little bit, and then it starts to stop bouncing as high, and then it just hits the ground. So this is the height that is following. And now number 7 says, what kind of function might model this the tennis ball bounce situation? Explain your reasoning with a table of values or other representation. So we know that these graphs are non-linear, right? This is not a straight line. So the other type of function that we could be looking at is an exponential one. So I'm going to say exponential. And instead of being a common change in terms of constant, it's changing by a common ratio. In this case, in the tennis ball example, it was changing by a ratio of 55%. Okay? Linear functions follow a constant. So it might change from 5 to 10, 10 to 15, 15 to 20. You are adding 5. In that example, you are adding 5 every time. With an exponential, it's changing by a common ratio or percentage. So I'm going to say there is a common ratio and I'm going to say not linear because change in height is not constant. And now number 8 says, look back at the table you generated in question 3. Write a function rule for bounce height in terms of bounce number. And graph the function rule with a scatter plot on your graphing calculator to see the function rule models. To see if the function rule models the data. So if I'm trying to write a function, more specifically a function rule, I need to look at, okay, what type of variables do I have? So I'm going to have h. We got to know the height of the bounce. And then n is going to be our bounce number. Okay? So h, that's what we're trying to figure out, right? Now something else we need to know is the original starting height. Well, we started at 2 meters, and we said that it is 55% of every bounce, after every bounce. So 2 times 0.55. And now, if you're trying to write a function rule, okay, this is going to be an exponential function, and it's going to have n be the exponent. So after every bounce, we're going to be adding another exponent to this function. So after 1 bounce, n will be 1. So you'd have 2 times 0.55. After 2 bounces, n would be 2, and then you're going to have 2 times 0.55 to the second, and so on and so forth. And number 9 says, what is the height of the 5th bounce of a new tennis ball if the initial drop height is 10 meters? So initial drop height is 10 meters above the ground. Use a function rule to find your answer. So we're going to be using this function. We're just going to change it just a little bit. So I've got h is equal to 10 times 0.55 to the nth power. And the reason I changed this is because in this problem we had 2 as our starting height, and this one we have 10 as our starting height. Now, we're looking for the 5th bounce. So in this problem, n, remember, is the bounce number. N is going to be 5. So I'm just going to take this 5 and I'm going to plug it in right here. So I'm going to have h is equal to 10 times 0.55 to the 5th power. And when we plug that in our calculator, we're going to get h is equal to 0.503 meters. So after 5 bounces, if you start at a height of 10 meters and it has a 55% rebound percentage, then you're going to end up with a ball height of 0.503 meters after 5 bounces. Number 10, it says, suppose a new tennis ball is dropped from a height of 20 feet. So I got 20 feet this time. How many times does it bounce before it has a bounce height of less than 4 inches, or the diameter of the ball? So we need to figure out, we are given the starting height, we are given the bounce percentage of 55% still, and we need to find out how many bounces it takes to reach 4 inches in height. So I'm going to have a function. I need to figure out what the function is first. So remember, our starting height, 20 meters. Bounce percentage, 55%, so we're going to have 0.55 to the n. And now I need to solve for n when h is less than or equal to 4 inches. So we know this has to be less than or equal to 4. We need to figure out what this value is. So if I were to take this on my calculator, okay, just imagine on your calculator you've got n and you've got h. And after 1 bounce, if you were to plug in a 1 right here for your n, you're going to have a ball height of 11 meters. After 2, you're going to have 6.05 meters. After 3, you're going to have 3.3 meters. So you can either plug this in manually 1 at a time on your calculator, or you can plug it in to the y equals section and then look at the table that it generates. So if I were to keep going down this list, just keep on going, I would eventually run into a 6. After 6 bounces, you would have a height of 0.55 meters, which is about, if you were to convert to inches, that's about 6 inches. So we're not quite there yet, but after 7 bounces, you're going to have a height of 0.304 meters. Now that is about 3.65 inches. So after 7 bounces, it will take 7 bounces to reach a height of less than 4 inches, okay? So after the 7th bounce.